Today's show is sponsored by Panoptica. Panoptica simplifies container deployment, monitoring, and security, protecting the entire application stack from build to runtime. Scalable across clusters and multi-cloud environments, Panoptica secures containers, serverless APIs, and Kubernetes with a unified view, reducing operational complexity and promoting collaboration by integrating with commonly used developer, SRE, and SecOps tools. Panoptica ensures compliance with regulatory mandates and CIS benchmarks for best practice conformity. Privacy teams can monitor API traffic and identify sensitive data while identifying open source components vulnerable to attacks that require patching. Proactively addressing security issues with Panoptica allows businesses to focus on mitigating critical risks and protecting their interest. Learn more about Panoptica today at panoptica.app. That's panoptica.app.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for Cloud News this week, but quick preview of what's to come after the cloud news. We have this week a great episode on API security with Filip Verloy, field CTO at No Name Security, and he's going to be talking all about the latest trends in API security and more. But let's jump into cloud news. First of all, Cloudcast alum and platform engineering, I guess you could say, spokesperson these days, Luca Galante did an article over at Stack Overflow and all about platform engineering. And platform engineering, the title is Platform Engineering is Just DevOps with a Product Mindset. He goes into some interesting kind of history of DevOps, which I feel like a lot of us, if you listen to the show, you probably know a lot of that. But he definitely goes into the cognitive load that DevOps and developers often face. And this idea of, hey, platform engineering is this new thing. Well, what truly makes it different? And it's this platform as a product mindset. This isn't a reinvention of the wheel. This is just an evolution of the way things are already progressing in the industry. Pretty good take on it. I liked it and I enjoyed the read, and definitely go check that one out. Now, for our second article, this one is, if that first one's a little practical, this second one is not practical. But I thought it was super interesting. Google has an RT2 AI model. Now, you might be thinking, what the heck is RT2? I haven't heard of that one. Well, it's WALL-E. It's Robotic Transformer 2. So it is what they're calling a first of its kind vision language to action model. So you can give a robot chat-like commands and it will use the GPT transformer technology to act out those commands. It's been trained visually on images across the internet. And then you can give it commands like if there's an apple in front of the robot, pick up the apple or move this object from here to here. There was one, it was a picture of Taylor Swift and it was move the Coke can to Taylor Swift and things like that. Is it practical? No. Was it kind of fascinating and an interesting read on how they came up with the technology to take voice commands or chat commands and put them into visual translation and do generative things against it? Yeah, actually it was. It was a really interesting read on that and always interesting to see new uses for AI. And finally, this one may be probably no surprise to those that follow the podcast, but venture-backed startups are failing at record rates this year. We've talked a lot about it. VC markets are getting a little harder. Interest rates are going up. Money's getting a little hard to come by. Starting to see some down rounds. Just headwinds all over the place. Well, so far this year, 54 companies with VC funding or private equity have failed. And at this rate, it's on average to track to about 108, 110 by failures by year end, which would be beating the record of 95 that was set during 2010. So it's an unfortunate time. We certainly wish everyone the best out there, but we also want to keep everyone informed. And certainly, if you're considering something like that right now, well, you might want to definitely look into funding and make sure if you go to a startup that they're going to have legs with them for the long haul. So with that, I'm going to wrap up cloud news, but just as a reminder as well, we're kind of in peak news season time right now. And by that, I mean, this was just a couple of the articles. There's probably close to 10 articles in the cloud news this week, and I only covered a couple of them in the interest of time. But if you want to know, there's a good explainer on how LLMs work. There's another one about how GPT models work. There's Sysdig did their 2023 Global Cloud Threat Report, and many others in there as well, covering a wide variety of topics. Definitely go check it out if any of those interest you. And with that, I'm going to close out cloud news for this week. And as I mentioned before, we're going to be talking about API security with Filip Verloy right after the break.
Are you looking to stay ahead of the curve in the latest trends in enterprise tech? Look no further than the Breaking Analysis podcast with Dave Vellante. This data-driven program dives into the most important topics facing the enterprise tech industry today. With a data-first approach that leverages ETR's renowned surveys of IT decision-makers and insight from the CUBE community, Breaking Analysis delivers in-depth research on the most important topics facing technologists and IT buyers. Whether you're a business leader, an IT professional, investor, or just an avid follower of the industry, this podcast is a must-listen. Just search Breaking Analysis Podcast wherever you get your podcast and tune in today to stay ahead of the game in enterprise tech.
And we're back and have a really good guest this week, and somebody I've been meaning to talk to forever now. And by the way, full disclosure ahead of time, we used to work together as well. So we get to catch up as well as talk about API security, which is our main topic today. So with us, we have Filip Verloy, Field CTO at No Name Security. Welcome to the show, Filip.
Thanks for having me, Aaron. Big fan of the show. Love what you and Brian have created here. So excited to be on.
Fantastic. Thank you. And like I mentioned, we've worked together at previous companies, and it's great to make that connection and catch up again. But for those out there that don't know you, tell everyone a little bit about your background and how you got involved in API security at No Name.
Sure. So I've been in the IT industry for over 2 decades now. So I've been doing this for quite a while. I started on the customer side, end user support, I think like a lot of us, then moved into like server administration, worked a lot with like Sun Solaris, but also like Linux systems, Windows systems, even Mac OS Server back in the day. What I noticed there at the customer side is that all of the cool sort of projects were done by external consultants. So I jumped over to consultancy, a fairly small shop. So I got to work on a broad swath of topics like, networking, storage, virtualization, a bunch of Novell to Active Directory migrations. But as part of a reseller, you also get to sort of attend a bunch of industry conferences like, Microsoft TechEd, VMware PAX, all of that fun stuff. And that's sort of how I got interested in working for a vendor, because that looked really, really cool. So I joined Citrix as my first vendor, and I never looked back really. So I worked at Dell, Riverbed, VMware, and then we were at Rubrik together, as you said. So I was the first field CTO at Rubrik. And then I guess sort of talking about APIs, they were really a big thing for us back then at Rubrik, like giving people the ability to automate their data management solution, like integrate it into a wide variety of tools and solutions. That was really a powerful thing for us back then. So that is sort of where APIs and the potential of APIs came to the front for me, even though they were more focused on the infrastructure side, less so on the application side, which is what I focus on today at No Name Security, where I'm the global field CTO, and we purely deal with API security, but mostly from an application side, sort of slowly moving into the infrastructure pieces as well. But 90% of our stuff is focused on people building secure APIs.
Fantastic. Thanks for that. And it's a really good intro into what we really wanted to talk about too, because APIs, you hear about APIs all the time, and we've talked about APIs many times on the show, but We haven't talked as much about API security, but I feel like there's lots of news about it on a very regular basis, but people don't realize it's API security, right? Like we hear all the time on the tech news of like, hey, data got leaked, or, you know, all these records got out, or all this private information is out there. And I mean, there's, you know, so many instances now of, you know, sometimes millions of records, you know, getting out there, and really high profile, well-known instances. Well, what at least I believe is often not reported is like how that happens, and how do those breaches happen? More times than not, it's APIs and improper API security. Is that a correct statement?
Yeah, that's actually a great point. So APIs, I would say, by their nature, are somewhat hidden. They're typically not something an end user interacts with directly. It's typically through a mobile app or something, or a website. So it's how applications communicate amongst themselves and sort of exchange data, but you don't really interact with them directly. So when you sort of see external reporting on a breach, it will be typically, as you say, described as a data breach, and then it's typically related back to that application or a specific company, which I guess to some extent is normal, right? That's how you garner more eyeballs. Like if you call out, well, this was a very specific API issue, that's maybe less of an interesting headline than saying like Twitter got breached and all of the data got stolen. But like if I can talk about one quick example, it's for like Moveit. So recently we had this Progress Moveit hack or attack, I guess, which was mainly a 0-day SQL injection issue, but it did add an API component as well, sort of in the second stage. The idea there is that attackers could misuse API deserialization. That sort of means like blindly trusting data coming from a third party across an API, and you can leverage that to perform like remote execution or to steal data. We did a pretty comprehensive blog post on that recently. So that's not always clear, right? So these things happen. They're like big news. Thousands of companies got breached due to the Moveit hack, but there's almost no mention of how an API played into that. Having said that, though, there's very visible API hacks as well. I already mentioned Twitter or X, maybe, as I should call it now, where they scraped a bunch of PII data. There was also the Peloton one a couple of years ago, where you could like access the Peloton API and get to other users' information, which was especially relevant those days because U.S. President Biden was a Peloton user at that time, and sort of getting his data, including his vital stats and stuff, would have been interesting information to have for some people. And then more recently, we had the Optus telco breach in Australia. Australia seems to be hit pretty regularly these days when it comes to API issues. So we had Optus, we also had Medibank. But with Optus, it was basically an unauthenticated API open to the public internet, and you could just query it, no authentication. If you knew what you were doing, you could just get all of the data out, and that was exactly what happened. Like millions of PII records got stolen out of this unauthenticated API that the company didn't even know was connected to the outside internet. So the other thing I would say is that we don't really know the extent of the problem, based on just public discourse or public disclosures alone. Just now, I think the SEC set like a 4-day deadline for public companies to report hacks. But, our own research, we did a bunch of surveys this year and also last year, where we sort of asked organizations like how did they experience API security issues in the past, or how many of them had issues or were breached. 90% of the people taking that survey, and of course the data is a little bit skewed there, because if you're going to answer an API security survey, you're probably going to be more interested in it. But 90% of those organizations surveyed said they experienced an API security issue, and of course we're not seeing all of them being publicly disclosed, but what is clear, I think, is that almost all modern software is built on APIs. The public clouds are served over APIs. Modern platform solutions like Kubernetes are served over APIs. So the problem will, keep on growing. It will definitely not go away anytime soon.
Yeah. And as kind of a follow-on to that too, because I'm sure in your day-to-day role, I mean, you talk to a lot of organizations, and what problems do organizations bring you in to solve? And let me maybe elaborate just a second on what I mean by that. Are folks bringing you in proactively before something happens, which is what they should do? Are they bringing you in reactively, like something has already happened and now they need to figure it out? And maybe another like part of this is like, why isn't just a WAF, and for those that don't know, a web application firewall, why isn't that just enough?
Yeah, I think sort of the proactively versus reactively depends a little bit on what's happening in their peer groups. So if they notice like a public breach happened in, I don't know, telco or like healthcare or something, then all of a sudden they sit up and take notice, and then they will reach out more proactively. What we see is that most organizations sort of struggle with understanding what they have when it comes to APIs. So building a comprehensive inventory of all of their APIs is step one in sort of figuring out like how exposed are we, what does our attack surface really look like, and then once we have that visibility, we can sort of focus on de-risking that environment, de-risking those APIs by sort of finding and remediating or nudging them into remediating any potential misconfigurations. The web application firewall angle is an interesting one. Like a WAF is an inline security device, right? So it sort of focuses on verifying transactions as they happen. But because it's an inline device, it can only see the traffic that passes through it. And a lot of the APIs that we deal with are either east-west, like internal APIs, meaning they don't necessarily pass through a WAF or not the types of WAF we're talking about anyway. Of course, there's like micro-segmentation and micro-firewalling, but a typical WAF doesn't see that east-west traffic. There's also like unmanaged APIs which don't pass through the WAF. There's unknown APIs, like developer APIs that are forgotten over time. But the real problem with a WAF is that even if you push all of that traffic through the WAF, it still lacks the context to understand how these APIs are supposed to work and what good versus bad behavior looks like. So the result of pushing all of that traffic through a WAF and then turning on like HTTP validation would be a lot of false negatives and false positives, because a WAF is sort of signature based. It's very good at spotting things like an injection attempt. Like you give it a bunch of input, it checks that that input is valid for a certain field, and it can filter out things like SQL injection and so on. But from an API perspective, that's not how these things fit together. Like an API represents the business logic of an application, which you cannot really capture beforehand in a static rule base because it's something dynamic. Think, for example, I'm building a new company and I'm gonna, build an e-commerce company, and one of the things I'm going to do is I'm going to ship my items out all over the world. I'm probably not going to build my own shipping platform. I'm going to use an API to integrate with FedEx or somebody like that. So how do you, from a WAF security perspective, figure out what that type of transaction is going to look like with that third party? What's the data that is going to get exchanged? How does it change over time? Like if FedEx rolls out a new version of their API, like how do we need to validate security? So you really need to learn the behavior up to the user level before you can really judge if the pattern that you are seeing is good or bad. So I would bet that all of the public API breaches are organizations leveraging a WAF. Like all of our customers, for example, have a WAF. They have an API gateway. And they really need those systems, but they lack the reality of the threat. They lack sort of the context. It's sort of like comparing like the Hubble Space Telescope versus the James Webb one, right? So they can both be pointed to the same part of space, but because of the added infrared spectrum of the James Webb Telescope, it can see a whole lot more. And that's sort of similar when it comes to WAFs missing that additional infrared context, if you will, that's sort of represented with APIs.
Yeah, that's fantastic. I really like that. That's a good explanation. Thank you. And let me kind of move on then, because okay, let's say an organization is convinced, but at the same time, a lot of times, a lot of organizations out there, especially anything security related, more or less API security related, can be a tough sell sometimes, right? And ROIs, like sometimes it's an ROI, but it's an ROI sometimes on an unknown of like, you mentioned earlier, like, hey, there might be, like, I'll use the term a rogue API or an abandoned API that's just like sitting in the corner somewhere and no one even remembers it's there. Like it reminds me of like back in the days of like trying to do server inventories or virtual, server inventories. So like, where the heck are all the machines? It's like, where the heck are all the APIs, right? And so like, what is the typical way to justify these? Is it through an ROI, or like, how does this happen a lot of times?
Yeah, I think I sort of agree with your statement there that like it's hard to figure out an ROI for something that's a bit of an unknown at the moment. So, and security in general is sort of seen as an insurance policy still quite a lot of times. Like it doesn't directly contribute to the bottom line. Like what's the business benefit of having it? I sort of liken security to the way that meerkats organize themselves, if that makes sense. So like the role of the meerkat is not to provide security, right? It's to build burrows, it's to reproduce, it's to forage for food. That's what a meerkat is supposed to do. But one of the meerkats in the group takes on the role of the sentinel. So they sort of stand guard and they look out and they warn the group of any potential danger. So the group as a whole cannot survive without the sentinel meerkat, and I think that's the same for security. So for something that hasn't happened before, the way that we approach it is we go with our customers like through a risk assessment. So what is the likelihood that something like an API security issue will happen? And like I mentioned before, 90% of our survey respondents had an API security incident before. So we think the likelihood is high. And then to get to the risk is like you take the likelihood of something happening and then you multiply it by the impact of when it happens. So we think it's a serious issue. And then part of that is, like, I work for a startup. We are sort of category building, right? This is not something that existed before, API security as a category, I would say. So we're sort of building this category from a customer perspective. You're not replacing something. So that means there's no existing budget. So you have to demonstrate a lot of value before the customer is willing to sort of move with you. And of course, you do that through various things. You do a proof of value, and then people sort of see, okay, what does a system like an API security platform, what does it bring to the table? And then typically they sort of sit up and take notice when we show them things like, oh, you thought you had X amount of APIs, you actually have 30 to 40% more APIs than that you thought you had, which is a typical finding that happens with our prospect base. So if you think about ROI is, or one way to approach it is, let's say you can be more competitive as an organization, right? So you can deliver new APIs more quickly and more confidently because they are secure sort of from the get-go, because you have like automated API security testing. So there's definite returns to be had there, even if you're not sort of strictly thinking about API security from a defensive position. And what's helping as well is, like, you see very large industry giants like Microsoft also reacting now to public API breaches. So I just saw a webinar by Microsoft Security where they called out APIs as the most common attack factor, and things like that, of course, really help a lot in terms of mind share. I would say it also depends a little bit on the customer as well. So we personally are working with about 25% of the Fortune 500. So I would say the level of customer sophistication is definitely a factor here as well.
Yeah. And one final kind of question on that before we move on to kind of journeys. I mean, is it a correct statement to say a lot of CISOs don't have developer backgrounds? And so does that also present its own set of challenges? Like when it comes to, I'm sure the CISO side of the house has to make a decision on this, but then the development side of the house has to be involved. And so how do you keep it from being, I don't know, too many cooks in the kitchen kind of scenario, right? And how does the CISO typically get involved?
Yeah, I think that's a fair statement. Like APIs have many stakeholders. Like there are definitely a lot of cooks in the kitchen, and all of those cooks sort of have their own tooling, right? So if you're like the pastry chef, you have your specialized pastry chef tooling, and that's similar to what we see with APIs. So for API security, we tend to work with the CISO organization. Again, to some extent, because it's a new category, so there's no existing budget typically. And then depending on the focus being more on the production versus the development side, we either work with application security teams or pure developers. And if it's developers, to your point, most CISOs typically don't come from a developer background. But if it's developers, we often talk about shifting left, which today is a bit of a divisive term sometimes. In our world, it sort of means making sure that everyone is responsible for API security, like starting from design over development to implementation. Everybody has to sort of do that with security in mind. But to be sort of successful with that mindset, you want to avoid like adding additional developer toil. Like everything is shifting left today, like monitoring, observability, security, testing. Everything is sort of shifting left. So if you want to go down that path, you have to make sure it's as seamless as possible. I think like nothing will make a developer lose interest more quickly than like forcing them to adopt their workflow or giving them yet another tool with yet another GUI, and they typically won't like that. But API security touches application security, network security, infrastructure security, cloud, mobile teams, API program owners, developers, etc., etc. So you need to be sort of a good ecosystem partner, and you want to integrate using your own APIs, as luck would have it, with like a broad swath of tools around you in order to sort of confidently move forward. But like I can't deny that it's it requires work, and definitely it requires some convincing. But we typically focus on the CISOs, I would say, mainly because it's a fairly new field, right, that we're sort of developing. Yeah.
Makes sense. And it's funny about the shifting left thing, because I feel like a couple years ago, the shifting left term, I mean, made perfect sense, and it was really valid, and I think really helped resonate very quickly what we're trying to achieve. But then it kind of got watered down because everyone started using it. And to your point, I think it's become a little divisive now, without a doubt.
Yeah.
But
I really like this concept of like, instead of shifting left, why don't we sort of shift it down, right? We make it part of the platform, or we make it part of the infrastructure and the tooling that we have. I think that's probably the better approach. But to some extent, it's semantics, right? We all sort of mean the same thing. And like, if you're open to working in that way, like developers, they want to develop secure applications, right? So they want to buy into this. You just have to meet them like halfway.
Yeah, that's right. Great. Well, and let's talk about that. So what are the typical steps in, I'll use the term a journey towards securing APIs, right? Like most organizations out there, let's just assume they have nothing, or they have a WAF, at best, right? Mm-hmm. So how far does the solution go, and in what steps? Because the reason why I say that is, like, of course, like you mentioned earlier, hey, you can identify a bunch of problems, but then does it move into, okay, great, I've identified a problem. Now I, automated remediation and or push button remediation and or monitoring and observability into it. Like, how does that journey go? Because obviously it's probably like a crawl, walk, run approach over time.
Yeah, that's exactly right, I think. So it's definitely a bunch of steps. So I think step one is building that inventory, getting visibility into what you have. Like, you can't protect what you can't see. So you really have to figure out what does my exposure look like. So getting an inventory is step one, and then sort of understanding my full exposure is sort of step two, but it also includes your external API attack surface, meaning what are all of the shadow domains that I'm exposing? What are the APIs associated with those shadow domains? Do I have like code examples that I pasted on Pastebin? Do I have API keys lingering on my GitHub accounts or in my S3 buckets? And here you can already take a lot of steps to sort of drive down the exposure of these organizations. So a lot of times we see things like routing misconfigurations. Like I've paid for, I don't know, Cloudflare or Akamai or some other CDN that's supposed to route all of my traffic securely to my backend systems, but oftentimes we see those backend APIs exposed directly to the internet anyway. So those things are easy to spot and easy to fix. But the real fix, I would say, or the major step on the journey is like looking at behavioral aspects. So figuring out what does good versus bad usage of an API look like, and especially when it pertains to the underlying applications, because an API in and of itself means nothing, right? It's just an intermediary between the consumer of the application and the backend application, and then the API translates what the front end wants towards the backend application. So you really have to see it in its full context. Today, I would say like most remediation is still manual, guided by inputs from like an API security platform, but we are definitely on the path of more and more automated remediation, which today already is realistic from an infrastructure level. Like, for example, there's a detection. Okay, we can like dynamically add or drop an ACL on like the AWS firewall service or something like that. But once we have to implement root cause remediation at like the code level of the API, that's still a bit further away, right? So in general, sort of APIs are a big part, maybe even the biggest sort of unknown part of your attack surface. So you have to make them part of your sort of defense in that strategy on that journey, really.
Yeah, and that's actually probably a perfect segue, and maybe it's the automated remediation. Or I was thinking back earlier when you were talking about WAFs and false positives and false negatives. Is this something, because I feel like mentioning AI ML, everyone's talking about it in every industry and every solution. And so I'll ask the obvious question then of, is this something where AI ML could play, and how do you see AI and ML in the future of API security?
Yeah, like talk about a divisive term, like
shifting left with AI ML. No, just kidding.
Yeah. We've lived through some of these cloud washing terms before and stuff like that. I definitely feel there's some of that going on here.
Yeah.
But I think in general, like APIs are, or I consider them to be at least like a superhuman problem. Meaning, if you compare the number of transactions between a traditional web application and an application powered by an API, it's a massive difference. Like there's so much more happening when you consume API-based applications in terms of the amount of traffic and the amount of connections and so on that you need to verify. So tracking those and linking them back to an individual user, and you have to do it over a long period of time to figure out if this user is malicious or not. Because an API attack is typically low and slow, as we call it, whereas like an injection attack, like that Moveit hack, for example, where you do an injection, that's like a one-off transaction. Like you're successful in doing that injection attack, that's like a one-off transaction, which you could sort of flag using a WAF. But with an API, it's low and slow, meaning there's a method where you can sort of figure out, well, what does this part of the API allow me to do? And what is the logic behind the API? Like, what are the logical steps that I'm supposed to follow to check out an item on an e-commerce site, for example? So because there's so much happening, so many transactions happening, that is where machine learning definitely has a role to play. You can sort of build a baseline of normal behavior, expected behavior, I would almost say, like, how are people normally interfacing with my APIs? You look at that, you build a baseline, and then once you have that baseline, you can start to look for deviations over time. And this is already happening today. So that's already implemented. That's part of what we do, for example, and others as well. So future-wise, we will probably see more automated remediation through AI. we already have like things like interactive documentation with like ChatGPT-like systems. I think the real fun stuff starts to happen if we can extend this to code validation, for example. So you have GitHub Copilot, GitHub Copilot X, you have things like, DeepMind Alpha Code. And so if we can determine, actually, it's a business logic flaw in the API, that's the root cause of this exposure that we're seeing here. And this is how you should change your API code in order to remove that root cause issue. I think then we're starting to get into some interesting conversations. But I don't think we're there yet, especially not in an automated way. But generally speaking, I would say security starts to look more and more like a big data problem. Like if you're crawling through, unspeakable amounts of log information, alerts, real-time incidents, that's really something that's ripe for machine learning-based disruption, in my opinion, especially in the early detection phase. Like if we can identify the patterns of a reconnaissance, for example, like what does an attacker typically do, and where would he look, and like what would he try to figure out before doing an actual attack, then we could close down those paths before they cause real harm. So their ML and AI definitely have a much bigger role to play, I think, going forward.
Yeah, that's a great point. It's a great point. And I kind of see it as like, AI ML almost has multiple uses, obviously, but the two that I think are emerging most is the generative AI, the ChatGPT things, of course. Mm-hmm. But then this, I'll just use the term finding the needles in the haystacks, right? Whether it's on big data, whether it's, streaming, things, it's always about, ingesting really, really big amounts of data and then making some kind of analysis and point analysis on it that humans just can't react fast enough to.
Yeah, that's exactly it. Yeah.
Well, fantastic. Well, why don't we close it out there? Filip, thank you again for your time. Super appreciate it. Where can everyone follow you, find out more about what you've got going on coming up?
Yeah. So thanks for having me on the show. It was really fun. I'm available on Twitter, so at Filip V, Filip with an F. I'm also pretty active on LinkedIn. So if you just want to look for Filip Verloy on LinkedIn, you'll find me there as well. So that's probably the two easiest ways to get in touch. I would love to chat to anybody reaching out.
Fantastic. All right. So thank you, Filip, for your time. I certainly appreciate it. And everyone out there, thank you very much for listening. And if you could do us a favor as well, if you're enjoying the show, please leave us a review. And if you have ideas for shows, please send us feedback as well, show@thecloudcast.net. And on behalf of Brian and myself, I'm going to close it out for this week, and we will talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.